In this video we will find fourth root of minus 16 iota, or this can be written as fourth root of minus 16 iota. So first of all, let x plus y iota is equal to minus 16 iota, or we can write 0 minus 16 iota. So the real part x is equal to 0 and the imaginary part y is equal to minus 16. So first of all we will find the modulus and the argument of this complex number. So modulus of this complex number is equal to r, which is equal to x square plus y square, and this will be equal to square root of 0 square plus minus 16 square. So the modulus of this complex number is 16, and then the theta or argument of the complex number, which is equal to tan inverse of y upon x, and this will be equal to tan inverse of minus 16 upon 0. So the tan inverse of minus 16 upon 0 is minus pi by 2. Now we can express any complex number x plus y iota in polar form as r times cos theta plus iota sin theta. Now since cos theta and sin theta are periodic function and their period is 2k pi, so we can write x plus y iota as r times cosine of theta plus 2k pi plus iota sine of theta plus 2k pi. Now we have complex number 0 minus 16 iota, so we will put the argument r of 0 minus 16 iota, which is 16, and then we will put the angle minus pi by 2. So we have cosine of minus pi by 2 plus 2k pi plus iota sine of minus pi by 2 plus 2k pi. Now this can be written as minus 16 iota is equal to 16 times cosine of 4k pi minus pi over 2 plus iota sine of 4k pi minus pi by 2. And now we will take the fourth root of minus 16 iota. So fourth root means this complex number has power 1 upon 4. So we can write whole power as 1 upon 4. So first of all we will write the complex number in polar form, and then whole power will be 1 upon 4. Now this will be equal to 16 to the power 1 upon 4 and cosine of 4k pi minus pi by 2 plus iota sine of 4k pi minus pi by 2, and this whole factor has a power 1 upon 4. Now now 16 raised to the power 1 upon 4 is equal to 2, and here we will apply the De Moivre's theorem. So this power will be multiplied by this angle. So we have cosine of 4k pi minus pi by 8 plus iota sine of 4k pi minus pi by 8. We have multiplied 1 upon 4 by 4k pi minus pi by 2. So we have 4k pi minus pi by 8. Now we will put 4 consecutive integer in place of this k. So we will put minus 1, 0, 1 and 2 in place of k. So we will get the fourth root of minus 16 iota. So the first fourth root of minus 16 iota will be obtained by putting k is equal to minus 1. So we have twice of cosine of 4. In place of k we will put -1, then plus iota sine of 4 times -1 times pi minus pi by 8, and this will be equal to twice of cosine of 4 times -1 is -4, so -4 by -pi is -5 pi by 8, plus iota sine of -5 pi by 8. So this is the first fourth root of -16 iota. Now for the second root we will put k is equal to 0. So we have twice of cosine of 4 times 0 pi minus pi by 8 plus iota sine of 4 times 0 times pi minus pi by 8. So this will be equal to cosine of 2 times cosine of minus pi by 8 plus iota sine of minus pi by 8. Now third root will be obtained by putting the value of k is equal to 1. So we have twice of cosine of 4 times 1 times pi minus pi by 8 plus iota sine of 4 times 1 times pi minus pi by 8, and this will be equal to twice of cosine of 3 pi by 8 plus iota sine of 3 pi by 8. Now then we will put k is equal to 2. So we have twice of cosine of 4 times 2 times pi minus pi by 8 plus iota sine of 4 times 2 times pi minus pi by 8, and this will be equal to twice of cosine of 7 pi by 8 plus iota sine of 7 pi by 8. So this is the fourth root of -16 iota.